So today we'll be studying mixed constraint in LPP. The problem is minimization. Z is equal to 6x1 plus 14x2 subjected to 5x1 plus 4x2 is greater than 60. So I have written is G greater. So x value is greater than the numeric value. This is the x value and this is the numeric value. And second, 3x1 plus 7x2 is less than 84. So I have written L here, the numeric value, x is less than the numeric value. X is less than the numeric value. That means the numeric value is greater than x. x1 plus 2x2 is greater than 18. So the value is greater than the x value is greater than the numeric value. So if there is a difference in maximization where you can see, or in minimization, the greater sign is either toward the x or toward the numeric value. But in mixed constraint, some portion will be at the greater, some subjected to will be at the greater side, and some will be to the greater to the numeric side. So the procedure will be same, but this greater and lesser sign will help us to find the feasible region. So convert inequalities to equal. So first 5x1 plus 4x2 is equal to 60. So 5x1 is equal to 60, comma 4x2 is equal to 60. So x1 is equal to 60 divided by 5, comma x2 is equal to 60 divided by 4. So x1 is equal to 12, x2 is equal to 15. Second, the process is similar. 3x1 plus 7x2 is equal to 84. 3x1 is equal to 84. 7x2 is equal to 84. x1 is equal to 84 divided by 3. x2 is equal to 84 divided by 7. x1 is equal to 28 and x2 is equal to 12. So this will be our x-axis. Point will be on x-axis. This will be on y-axis. Similarly here, on x-axis, on y-axis, x1 plus 2x2 is equal to 18. So x1 is equal to 18 and x2 is equal to 18 by 2. So x1 is equal to 18 and x2 is equal to 9. So the procedure for maximization, minimization and mixed constraint, finding the points on the graph x and y axis is same. So x I have copied here, 12, 15, then 28, 12, 28, 12 and 18, 9. Now we'll see the graph. So in this graph, I have write down the point x-axis and y-axis and copied the same point 12, 15, 28, 12, 18 and 9. So 12 on x-axis. So you can see 12 to 15. So 5x1 plus 4x2 is greater. So greater, I will have placed an arrow. So this will be the side to find the feasible region. Second is 28, 12. So on x-axis it is 28. So here the point 28 moving towards 12. You can see in the blue colored line, light blue, or we can say sky blue. Okay. So the equation is x is less than the numeric value. Here I have written. So the region is inside. Okay. The value is less. So I have put the arrow towards the downward direction. Now here it is 18 and 9. So I have just drawn the line from 18 x-axis to 9. Okay. So the value is greater. You can see in the equation. I have not written the equation here. So I have put towards the upper side. Okay. So we can find the feasible region. So this is for the lesser and this is for the major. So this will be our feasible region. Okay. And the points we can find it out. That is on x-axis it is 3. And on y-axis it is 8. So I have written 3, 8. So the B point is here, it is 8. Okay. and from here it is 5, on y-axis it is 5, so I have written 8 comma 5. Okay, then on point C it is 18 comma 0, x-axis 18, y it is 0, it is, we can see it very clearly. On D point it is 28 comma 0, 28 on x-axis and 0 on y-axis. So our extreme point is 3 comma 8, that is 3 8. On B it is 8 5, you can see here 8 5. On C it is 18 0, 18 0. On D it is 28 0. So this problem is of mixed constraint. Okay, so we have find the feasible region with the help of the greater and the less sign. Now here you can see the extreme points. I have already copied down: A, B, C, D, 3 comma 8, 8 5, 18 0, 28 0. So the z objective function was 6x1 plus 14x2, 6 into 3, that is x1 value, I have written here x1 value, and 14, and x2 value is 8, is 130. Then 6 into x1 value 8 plus 14 into 5, 118. Then 6 into 18 plus 14 into 0 is 108. Similarly 6 into 28 plus 14 into 0 is 168. So the minimum value